Okay, everybody ready? Yeah. Okay, so I think this is personally I feel this is a really important topic, and it's maybe something good that we get it out of the way earlier on, because it will enable us to write more interesting programs as the kind of course goes on. If you kind of know this stuff now, and please, I would just ask everybody to please concentrate this class, and please work hard to make sure you understand this, okay? And if you don't understand this, anything in this, just take a point of asking me now, right? And nail this thing, because it will enable you to do a lot of really more powerful stuff as the course kind of evolves. Is that okay with everybody? So if there's the slightest thing you don't understand, then put up your hand now and say it as we're going through this thing. Is that okay with everybody? All right, don't wait and don't say, geez, I didn't have a clue what that class was all about. All right, it's not that hard, by the way. It's junior cert math stuff. So, but it's just for some of you, maybe a long time since you did your junior cert. Anyway, how many people here did honours maths in the room, just out of curiosity? How many people did ordinary level maths? Alright, you don't have to do honours maths, but this is certainly very far away from honours maths. We learned last week that we can make, we can do certain calculations based on these rules of sine and cosine and tangent, right? And just as a quick recap, okay, if I pick any old triangle, I can pick any old angle, and so long as this angle here is 90 degrees, then these sides, the ratios of the lengths of these sides obey certain rules. We discovered that last week, okay? And those ratios, the three ratios that we have, if I have this right angle triangle here, and this is we call the opposite, this is what I call the hypotenuse, and this is what I call the adjacent side of the right angle triangle. We can say stuff like that the sine of the angle theta is equals to the length of the opposite side over the length of the hypotenuse side, okay? We can say that the cosine ratio is equals to A over H, okay? And then the tangent ratio, tangent of theta is equals to O over A. So we also realized yesterday we can use this to solve certain problems as well. We can use this to calculate one side if we don't know the length of one side, okay? And we can even write a processing sketch to prove that this math actually works. And you can see, as you're expanding and contracting the sides of the triangles, you can see the calculations happen in real time, because we've written code to do that. So, the next thing I need to talk about, right? So everybody's happy with that? And the sketch last week, did everyone manage to complete it? Yes. If you didn't manage to complete it, I put the solution up, so you know, remember we all signed a contract, or you guys all signed a contract, that if you didn't complete a lab, you got to go and download it or complete it in your own time and study the solution. So I'm assuming everybody has done that, and everybody's clear about how that program works, okay? So the next thing then is, normally when we're measuring angles in programs, computers typically use the radian system rather than the degree system. So how the radian system works is we take an old circle like this, and we say that that's 0 up there, and then we count around the outside of the circle in units of the radius. So if this is the radius of the circle here, then we take the length of this and we walk out the length of that radius out around the circle, and we realize that once we've gone here, how many times the radius will we have gone? Well, count it. I mean, you can look at it. Certainly not 3.14. Like 3 is not big enough. Like that's 1, that's 2, and that's 3 there. Roughly 3. We go 6.28 times around the circle, okay? 6.28, etc., around the circle. And that's how we get this idea of radians. Radians basically tells you how many times you've got to walk the outside of the circle by the radius of the circle. And again, you can imagine that as this circle grows and shrinks, the radius is going to shrink, and so is this outside of the circle, which we call the, what do we call the outside? We call it the circumference of the circle, all right? So it's basically pi times the diameter, or pi times twice the radius, will tell you what the circumference of the circle. And that's where you get the unit of measurement called the radian from. It means how many times you walk out the radius out the outside of the triangle. Is that okay with everybody? So a couple of little simple, ones to imagine. We notice that if I walk out this amount here, how many radians does it take to get as far as here? How many times walking out the radius do I have to get to this point here? It's going to be? Pi. It will be pi times the radius. Pi being this number 3.14. Okay, so if you take the radius and you walk out once, twice, 3 and a bit, you will find that you'll have reached the bottom point of the circle here. And we call that number pi. Okay, so pi gives you that far. What about if I wanted to get this over here? Just go as far as the first quadrant of the circle. How many times would I have to go? It's going to be pi over 2. So this is pi over 2. So these in degrees. So what's pi over 2 in degrees? It's 90 degrees. If you want to walk out 90 degrees in this direction here, it's the same as walking pi over 2 times the radius around the outside of the circle. Is that okay with everybody? It's pi over 2, because if this is pi, this is half pi. So this is going to be pi over 2. What about if I wanted to walk out as far as here? So in degrees, this is 90. In degrees, this is 180. Over as far as we get here, how many radians would we walk out?
3 pi over 2.
It's going to be 3 pi over 2, or 1.5 pi. Right? So 3 times pi. Let's think about this for a second. 3 times pi over 2. That's pi, and then we go another pi. Yeah, so we go another half a pi to come up to here. So you get 3 over 2 times pi. So 1.5 pi radians to get to that point on the circle. And that number there is the same as 270 degrees, isn't it? So you have 180 plus 90 is going to be 270 degrees. Okay with everybody so far? So this is the radians measure. And when you go all the way up to here, you'll have gone 6.28 radians. You'll have gone the entire radius of the circle. Is that okay? Now, or the entire circumference of the circle. Is everyone following that so far?
Yeah.
Quick question for you then, right? As a general rule, if I was to take something like 45 degrees and I wanted to convert that to radians, what's the algorithm I use to convert that to radians?
Multiply.
Do you know what I mean when I say algorithm? What's the process? If I want to convert that to radians, what would I do?
Multiply by pi and divide by 180.
Exactly. Where did you get that from?
Because one pi is equal to 180 degrees, so that's what you're dividing by 100.
Yeah, exactly. So 1 pi is 180 degrees, or you can do it the long way around. You can say, well, okay, that's 45 degrees. What fraction of 360 degrees is that? So you can take 45 divided by 360, and then you multiply by 2 pi. So that basically tells you what, because if it's 360 over 360, it's going to be 1, and then you multiply by 2 pi gives you 2 pi. Alright, so if this was equally 180 over this, you would get a half. So you take a half multiplied by 2 pi is going to give you a pi. So a simpler way of doing this, rather than divide by 360 and multiply by 2 pi, is just to take the degrees value, which is 45, divided by 180, and then multiply by pi. So that's our equation for converting between degrees to radians. To go the other way around, you can take the degrees value, you can take the radians value. So if I had 6 radians, and I wanted to convert that to degrees, you use the same thing but in the opposite direction. So what would the equation be? You would divide by pi and multiply by 180. So you can take 6 radians, divide by pi, and then you multiply by 180, and that's the way to go in the opposite direction. In terms of the processing framework, when you want to convert between degrees and radians, because sometimes it's easier to think about angles in degrees, but when we want to use sine and cosine and stuff, we need all those values always in radians. So then we can go radians, radians, then you pass in something like 90, and returned out of this method is the value in degrees. Similarly, you can go degrees, and you pass in we'll say pi, and in that it's basically the word pi like that, and it will return you out the value in radians. Is that alright with everybody? Okay, do you recall earlier on in the year we wrote a lab where we got something to drive around the outside of the screen? Remember that one? Remember we wrote the if statement? Do you remember that? Everybody remember how it works? Okay, this time what we will see if we can do is instead of getting our little something to go around the outside of the screen, using the if statement, we'll see if we can use this little bit of trigonometry to get our thing to move in a circle. Won't that be exciting? Once we can get things to move in a circle, it gives us a lot of power, because we can move things in a circle, we can also draw circles procedurally, and we can also get things to move in circles, and we can mess with the radius that will enable us to draw all kinds of beautiful and amazing geometric patterns by writing very little code and by applying our little bit of trigonometry. I'll explain to you how you do that. So before I go any further, sine, cosine and tangent, you've nailed that, yeah?
Yeah.
Radians and degrees, we've nailed that. We're happy we can convert between the two. Everybody knows what radians are, everybody knows what degrees are. If anybody wants to ask a question about any of this stuff, now's the time. Yeah?
What exactly is a radian? Like, I know how to convert, but what is a radian?
A radian is a unit of the radius. That's all it means. So it's how many times you need to walk the radius around in order to get to, to calculate the circumference of the circle. So that's why I'm saying if you take the radius as 1 here, you would find that you walk 6.28 times around the circle. If that was 10, you would walk 62.8 times. If this was 100, you'd walk 628 times multiples of the radius around the outside of the circle. That's what radians mean. When I did trigonometry in school, I was told that there was 6.28 radians in a circle. Nobody ever told me why there were 6.28 radians in a circle. It was just some number that you had to realize. I never realized it meant units of the radians, but you think about it, it's obvious. Because that's the equation for calculating the circumference of a circle. You take 2 pi r. That gives you the circumference of a circle. That's why there's 2 pi radians. Does that make sense? Everybody happy with that? Okay. So, let us imagine in processing that I have a little circle here. And here's my circle. Okay? And let's say that for the sake of argument in processing, the center point of this circle is located at position 0 and 0. Would somebody mind just having a quick look at the screen on that camera and make sure that it's in frame and that you can see me and see everything? Does it need to be moved or anything?
No, it's fine.
Can you see me?
Yep.
Good, okay. So, there we go. 0, 0 being the center point of the circle. Let's imagine that I want to draw a simple circle, and I want this circle to be of radius 1. It's not going to be a very big circle, and in fact, if it was radius 1, it would just appear as what in processing? A dot, okay? But for the math purposes of this, it's easier if we can figure it out that it's just of radius 1, alright? So, let's imagine that this is a circle of radius 1, and if that was the point 0, 0, then what will be this point up here?
0, 1.
Excellent, excellent, great. That point would be 0 and minus 1. Cool, so you totally got this, this coordinate system. You can see that we're going up minus 1. Yeah?
In processing, I thought you wouldn't be able to draw like above, or you wouldn't be able to see it anyways. That's what's going to happen if, say...
Yeah, in this case, you just wouldn't see it, right? But we'll expand this. This is just the theory, if you like, right? And then we'll actually put some other numbers apart from 1 and 0, 0 into this. So, but it's easier to conceptualize this initially if we imagine that it's of radius 1 and centered at 0, 0. Is that okay with everybody?
No, sorry. How is the 0 minus 1 there on top?
Sure. Because in processing, the origin 0, 0 is here. And if I want to go down, I'm increasing the y. And if I want to go up, I decrease the y. So that was why it would be minus 1 as opposed to 1. Does that make sense? Good question, right? Does everybody understand why it's minus 1 and not 1? It's because the coordinate system is in the top left-hand corner. If I wanted to pick a point above 0, 0, it would have to be a minus 1 point on the y. Okay?
Why would you pick a point above?
Well, again, as I say, this is just the theory.
The top left, isn't it?
Yeah. It will be off the screen.
Yeah.
So we'll do this in theory, and then I'll show you how we can move it to the center of the screen in a minute. And also how we can use a radius of something other than 1. It's just easier to explain this if we assume it starts at 0, 0 and a radius 1. And in a minute I'll show you how to change it so that it's a different radius and a different center point. Is that okay? Okay. What would be the coordinates of this point here?
0, 0.
Yeah, this would be 1 on the x and 0 on the y. And this point here would be? So it would be 0 on the x and 1 on the y. And this point here would be? Minus 1 and 0. What about this point here? Let's pick a point which is maybe might appear on the outside said to be kind of obvious. Let's pick this, which is halfway between those 2 points. What would be the coordinates of that?
0.5.
What's that?
0.5.
Okay, we'll put in a couple of potential numbers. Let's say we pick 0.5 and minus 0.5. Does that look kind of alright?
No.
What's that? Oh yeah, so this should be over 0.5 and 0.5, no?
0.5,
0.5, 0.5. So 0.5 will be this point down here. Yeah.
That would make it a point on a line being drawn directly from the top to the side.
Gold star for what's your name?
Ross.
Ross. Of course, it's not 0.5, 0.5 because this is the point 0.5, 0.5. Okay? Does everybody see how that's the point 0.5 to 0.5? It's not the point on the circle. But initially when we look at it, we might think, yeah, it's halfway between, it must be 0.5, 0.5. Any other guesses?
0.75.
Yeah, 0.75, so it's clearly, you know, it's not quite 1, because 1 would be all the way up to there, and it's not quite 0.5, so it's going to be somewhere between that and that. It's roughly 0.7 something, we think it might be.
0.75.
Might be.
0.75. Minus
I don't know.
0.75.
Good guess. Tell you what, yeah.
It's root 2 over 2.
Root 2 over 2.
I know there's a root involved.
Let me think about that for a second. Root 2 over 2. I'll tell you what, let's work it out in maths and see if root 2 over 2, how did you come to that conclusion?
I just know that it's...
It was in the logs, it's from the maths table.
That's in maths tables, okay. So you Googled it basically.
I don't have maths tables written.
No problems, yeah. No, but it is a number, but it's actually a number that's very, very easy to calculate. And I'm going to explain to you how to calculate it, right? So this is the bit I need everybody's full attention. So if you need to, now's the time to stand up, have a bit of a shake, slap yourself across the face, but make sure you're 100% with me in this, okay? You followed up to this point. The fact is, you already know how to calculate this point. But I shall explain it to you anyway. So first of all, what we do is pick that point over there and we make our old friend a right angle triangle out of it, like this. If I put a 90-degree angle in there, and then I basically say that this is my angle theta in here, then I can see that, you know, this side here, you know, this is the distance from here to here is actually, that's my opposite side, isn't it? This is my adjacent side, this is my hypotenuse side. Okay, that's my right angle triangle there. Everyone with me so far? Can everybody see how I've made that right angle triangle? Now here's the bit which sometimes confuses people, but it's actually not very, I don't think it's that hard, but sometimes people get really, what, oh, okay, cool. Opposite. Can't I replace that with x? Because it is the distance from here to here, and this is 0 on the x, and this is the number I'm looking for. You know, if this is x and y here, then this value here, which is the opposite of this triangle, is the x. Does everybody see that? Similarly, this adjacent side is the y side, isn't it? Can you see that? This is the same as the y value that I'm actually trying to calculate. So these numbers here can be calculated based on, they're just the sides of that right angle triangle. Now before I go any further, I presume everyone is taking this down and has drawn this. And is making their own notes and drawing in little lines and putting in red arrows and stuff to explain what everything is. So please take out a pen and write this little diagram down, okay? And memorize this for all time. If you memorize this for all time, you'll be able to do amazing things, I promise you. This is a magic spell that I'm giving you today. This is like Harry Potter. Only better.
Oh yeah.
Okay, as you're taking all of this down, let me finish this off, and then we will write a program together to show you how all of this thing works, okay? Let us try and calculate x and y based on what we know about the ratios of the lengths of sides in right angle triangles. So, given that I can say some angle theta that is going to go around the outside of the circle like this, and let's just say I know what that angle is, right? How do I calculate x and y?
Did you use tan?
Tan. Given theta, but I don't know x and y, I need to calculate them.
You're given h.
You give it h, yeah, so what one would you use? To calculate x, what one would you use? To calculate x, which of the three do you use? Sine. Okay, so x is the sine, right? Because I'm looking over here and I'm seeing x is the one that I don't know. The sine of theta is equals to the x over the hypotenuse. Okay? Let's write this up and we'll write it in terms of x and y. So now I can say that the sine of theta is equals to the x value over the hypotenuse. Hypotenuse for us is what? It's the radius, isn't it? So to get that in terms of x, in other words, x on one side, everything else on the other side. Remember I said this to some people who were in my lab last week. There's two very simple algebra rules, you know. Algebra rule number one, I can multiply both sides by or, and I end up getting sine of theta times or is equals to x. Now there's a few people who found that rule a little bit confusing, right? But it's just a simple maths algebra rule. And it's very logical when you see it explained, or it'll explain how this rule works. It's a little bit of an aside. Let's say I have this number. 2 is equals to 10 over 5. Everybody agrees that that's pretty self-evident. So you take 5 into 10, you get 2, don't you? What would happen if I multiplied both sides by 5 and applied this rule over here? You would end up with 2 multiplied by 5 is equals to 10. So you get rid of this one over here, you multiply both sides by 5. Everybody see that? So that's the algebra rule I'm applying in order to get everything in terms of x over here. Just multiply both sides by or, and then you get sine theta times or is equals to x. What would happen if the radius was 1?
Sine 45.
How would that be rewritten? You would just get rid of the or, because when you multiply something by 1, it's just itself. So if our radius is 1, then it's just x is equals to the sine of theta. This circle that has a radius of 1 has got a special name in mathematics. Does anybody know what it's called?
The 1.
If it has a radius of 1, the circle is called a unit circle. Awesome. So, that's the first thing. So sine theta times or. What about y? What will we use for y? Tangent or cos? They're the only two that are left. Cos. So we'll use the same thing. You can go the cosine of theta is going to be equals to y over or. And then you multiply both sides and you go cos theta times or is equals to y. Now an interesting thing here. The x value over here, is it positive or negative? The x value. The x value is positive, right? The y value, is it negative or positive? Negative. So using our circle laid out like this, if my y's went in a different direction, then I would use positive and negative differently. But because my circle is laid out like this, sine theta equals x and minus the cosine of theta times 4 is equals to y. And that's because if I just use the cos of theta, what I'll do is I'll calculate this point. I'll calculate a positive number. So I need to make that positive number negative to make the y go in the right direction. To make the y go up, the negative y to go up, then it's minus the cosine theta times or is equals to the y value. Is that alright with everybody?
Yeah.
Awesome, awesome. This is called a unit circle. Now what we can do is we can write a processing sketch, right? And we'll think about what this sketch needs to do, and then we'll write it together, and then maybe I'll get you guys to make some small changes to it, okay? What we can do is we can write a processing sketch. Now we know how to make variables, don't we? Let's make a variable for theta in our processing sketch, theta. Let's make variables. Oh, sorry. How do I move this circle to the center of the screen? Because currently I'm just calculating everything based on the circle being located at 0, 0. Yeah?
Divided by width and height.
Divide what by width and height?
The radian.
I'll tell you what, let me phrase it slightly differently, because we do have to divide something by 2, but yeah.
You make a variable for width and height and then divide that by 2, and that'll get you the exact center.
That'll give you the center, and then how do I change the points on the outside of the circle? Easy, you know it. You just...
The center point at the middle, after we half height.
Sure thing, perfect. How do I move my x and y generated coordinates to those? Because at the moment when I'm generating them using these little equations here, they're going to be based on the center being at 0, 0. How do I get it so that the center is actually not at 0, 0, it's at some other point?
Make a variable for...
So let's say we declare some variables called cx and cy, which are the center x and center y of the screen. What do I do to these generated x and y, the sine of theta and the cosine of theta things? What do I do to these to move these points?
Cx plus.
Awesome. That's all you do, okay? To make this so that it's not centered at 0, 0, all you do is you add the center points to those generated values. So our final little equations become like this. To calculate the x, you take cx plus the sine of theta times the radius. And to calculate the y value, you take cy minus the cosine of the angle theta times the radius that we're looking for. So all I do is just add. At the moment they're centered at 0, 0. If I want to move the circle somewhere else on the screen, I just add the location that I want it to move to. And that, you know, just adding this to these generated values. If I calculate these around a circle at 0, 0, if I just add the center of the screen to it, then it moves the circle to be the center of the screen. Is that okay with everybody? Awesome. I think it's time to do something amazing. I think it's to write some magic, to make some beautiful things come up on the screen, and to thrill us all with the amazing power of programming. What do you think? Yeah. Is everybody excited? Yeah. Good, good. Let's do it. Oh, but just before we do it, I just need to be 100% clear. Has everybody understood all of that? Does anybody want to ask me any questions? Okay, ask me a question. You need to give me something to go on, right? Was there a particular point that I lost you at? Because if it's just you, it might be other people as well. So you might be just
Up here on the left,
yeah, this bit here.
why it became cosine as well. You said you had a value for y. What was the value for y?
The value for y was this one here, and this is the y bit here, right? So if we look at this right angle triangle, you can see that y is the adjacent side of the triangle. Yeah, if I take the y out there and just put in a for adjacent, you see that's the adjacent of that angle there. So the circle is located at 0, 0. So, you know, the distance from 0, 0 up to this height here is the same all the way along there. So that y value is actually the adjacent side of the triangle. The length of the triangle is the y value that we're looking for. Does that make sense? Yeah. Don't worry, this is the thing that confuses a lot of people when they see this for the first time.
You seem to talk about like you do.
Look, you work on it.
What the value of y?
We don't, we're calculating what you Alright? So to calculate the value for y, what I do is I use the cosine. So you can see that y, if I know the value for theta, that's the one thing we do know, is the value for theta. We're given the value for theta, we need to calculate y.
We got that from sine.
We got x from the sine, because x is the opposite. To get the adjacent side, we're going to use the cosine. The cosine thing is the y bit. Yeah, so that's the y value there. So that's why I can say, for example, in that right angle triangle, you take the circle out of it all together. You just imagine that's a right angle triangle. You can say that the cross of the angle theta is going to be adjacent to the y over the hypotenuse, which is the radius of the circle. That's where I got cosine. So then if I multiply both sides by 4, you get the cosine. That's where I get that from. Clear it out? The other thing is, like, it's currently just centered at 0, 0. So if I want to move this circle over to some other point on the screen, I just take this coordinate that I want, I just add in the distance I want to do. So I add the center point. Currently when I'm calculating this, I don't think, we don't care where it's centered. It's not relative to this, just the size of the triangle. See that it's adding. The circle is located at 0, 0. This point here is going to be 1, 0. That's 0, 0. And that point is going to be 1, 0. This point is minus 1. I really want everyone to understand this. It's not that hard. It's so
The center of the circle is
okay. Alright, no problem. Is it a bit clearer now? When we write some code, you'll see what you can do with this. Right? And what it says is if you watch back at this video afterwards, and at the point where you lose it, just rewind it and play it back. And if you have any questions, ask me on the Slack. Okay, everybody ready? Just before we move on, okay, one person brave enough to ask a question. Does anybody else want to ask a question first? Yes?
What was the last part about? I didn't kind of catch it at all.
Sure. So this x and y points that we're calculating this based on the fact that the circle is located at located at 0, 0. So what I want to do now is move the circle, say, into the middle of the screen. So all you do is you add what the new center is. If I want my circle to be centered at, say, width divided by 2 and height divided by 2, you just add in the center x to this little calculation that we get here. And it's just a matter of moving it. Say if you calculated the number 5 and you wanted to move it to 15, what would you do? You would add 10 to it. So at the moment I'm calculating it relative to 0, so I just add in the distance that I wanted to move to. In fact, you know what? When we do the little example, what I'll do is I'll show you what happens if you don't do this. The circle gets created in the top corner of the screen. Then if we add it, we can move it, that sort of thing. Is that okay with everybody?
Yeah.
Right, let's write some code. Okay. So if everyone can fire up processing, we'll create a blank sketch and we'll do all of this from scratch. Now I'm going to do a program first by myself here. You guys can follow along. And then afterwards, I think what I'll do is I'll get you to make some changes to the program just to make sure that you understand how everything works, okay? So first of all, and in fact, this is your opportunity to really go wild and really make beautiful things today, okay? And definitely I want to see lots of pictures up on the Slack. Will you just tell me, can that video capture me standing here? Because sometimes I do these videos and I'm out of shot and they just look a bit silly, like a disembodied voice, Will you make sure that I'm in it and you can also see the screen most importantly?
Yep.
You still see the screen?
Yep.
Okay, everyone got processing fired up? Yes. Blank sketch. What's the first thing we put in? Void setup. Void setup. I'll zoom in so we can see it a bit better, right? Void setup. Let's make our screen of size 500 by 500. What's the method we use? Size.
That's 50.
Okay, I want the background to be all black.
50.
Yeah, thank you. I want the background of the screen to be all black.
0.
Okay, so I go background. Okay, now. Okay, now I want to declare a variable, and I want that variable to hold the position of the center of the screen. Where do I put my code? Because I want to use it in both the setup and the draw method.
Outside.
So I put it outside, and what do we call that type of variable? It's a global variable. Alright, where do I assign those values?
Inside the variable? No.
Should I do it here?
No, setup.
No, we do it in the setup.
Why do you put your global variables underneath setup and not at the top?
No good reason.
No.
We can put it up at the top as well.
Yeah, just a preference though, it doesn't matter where it is as long as it's outside. But
Yeah, you're right, it doesn't matter. So long as it's outside those other two methods, it becomes a global variable. Means we can use it inside setup and inside draw. So then we do the assignment in here because we have to do the assignment after we call size, right? So you can go Cx is equals to the width multiplied by 0.5f, and then Cy equals the height multiplied by 0.5f. So I basically make my Cx and Cy equals to the center of the screen, 50% of the width and 50% of the height.
Why does like assigning the variable number go and set up and declaring it goes inside?
Yeah, we could do it up here. The problem with doing it up here is the values for the width and the height variables don't actually get set by processing until this method size gets executed. So if you put it outside, then width and height will have the values of 0. Let's make one other variable here called theta. And it doesn't matter because I'm just going to assign the value 0 to theta. So you can just go theta equals 0.0f. You can do the declaration and the assignment in the one line. Next thing, in our draw method here, let's calculate some values for x and y. Alright, so let's go float x. Now we said when we worked this out earlier, we said that x is equals to the center x. In fact, let's not do the center x bit first. Let's just do, without transforming it by the position center of the screen. But we did say that x was equals to the sine of the angle theta multiplied by the radius. Okay, that's another variable we need. Let's go float. And let's say radius is going to be equals to, because we don't know the width of the screen, let's say radius is equals to 200, just for now, okay? Alright, so down here, sine of theta multiplied by the radius. And then we go float y is equals to the cosine of theta, sorry, minus the cosine of theta, multiplied by radius. Okay, let's draw a little circle then. So to draw a circle we use, which method? So ellipse takes 4 parameters, the x, the y. Now this radius is different to the value of radius, the variable. The variable radius is going to be the positions that I'm going to calculate. This value for the, the width and the height is a different number I'm talking about. This is how big I want those small circles to be drawn. So I can go ellipse, and let's make it sort of 10 times 10 by 10, okay? Now I want to do something interesting. I want these circles, every time the draw method gets called, I want to use a different value for theta. If I just write my program like this, what will happen if I run it? It's static. Will you even see anything on the screen? No, because what's the initial value of x and y I'm going to calculate? 0. Try again. Sine of theta and minus the cosine of theta, straight up. The initial point at the very top is going to be what? Try again. If you don't believe me, type sine of theta into your calculator and tell me what you get. Sine of theta is going to be what? Type sine of 0 into your calculator and tell me what it comes up with.
Oh, it's minus 1.
Sine of theta is going to be 0, multiplied by the radius is 0. Minus the cosine of theta will be, so the cos of 0 is going to be what? Type it into your calculator, see what happens. Cosine of 0 is 1. So minus the cosine of theta will be minus 1 times the radius. So obviously the 0th point is right at the top of the circle. So in this example here, minus the cosine of theta, this is going to be 1 multiplied by the radius, and it's a minus number, so it's right at the top. Of course, it has to be. That's the 0 point of the circle. And as we go around increasing the value for theta, we're going to get points along the outside of the circle. But when theta is 0, we get the point right above at the very top of the circle. Okay, we can see this when we run it. Anyway, to get this to do something interesting, what we need to do is modify the value of theta. Theta plus equals to means what? Plus equals to means what happens to theta? We add something to the old value of theta, right? So this is like a plus and an assignment in 1. Let's pick the number 0.1f. So 0.1f is just a number that I've picked, basically a small number. Okay, and let us zoom out here and see what happens when we run this sketch, okay? Everyone excited?
Yeah.
Let's click the play button and see what happens. Oh my god, look at that. I'm getting all of these circles drawn up there.
Will that crash eventually?
No,
Really?
it will go on forever.
Until you
What's happening here, it might eventually crash. What will happen is it'll overflow the value the maximum value you can hold on a float, which is a really, really huge number, but you may have to wait until the end of the universe for that to happen. Let's do that. Now, you can see now, okay, so what's happened here? Does everybody understand why this circle gets drawn like this? Why this bit of a circle gets drawn?
background.
Yeah. It's usually the draw, there's no background being set. So
Yeah, but do you understand why this shape is drawn now?
Oh, well, yeah.
Sure, it's on your quarter.
Yeah, it's because it's actually drawing the full radius of the circle, but my circle is centered at 0, 0. So let us change the circle and let us modify it so that instead of just doing this thing, we do the last bit, which is to go cx plus sine of cosine, sine blah blah blah. And then let's try cy minus the cosine of that thing, and click the play button now and see what happens. So now we get our circles drawn around the outside of the circle. Every time the draw method gets executed, what's happening? It's adding a little bit to the theta variable, and so therefore it's continually increasing this angle. An interesting thing about angles, right? Angles wrap around. Once you get to 6.28, 7, 8, 9, 10, 11, 12, all the way around to 12 radians, 24 radians, all the way around. As theta is increasing, it just goes around the circle over and over again. Does everybody understand how this sketch is working? Yeah.
My question is, why does it move over a tiny bit more every time it goes around? What's that increment from?
That's the theta value.
Oh, okay.
So theta is increasing by 0.1 radians every frame, And so therefore, the angle, the value for x and y that I'm calculating, every time I redraw the screen, I'm using a slightly bigger value for theta. Yes, sorry, Ross, isn't it?
Yeah.
Yeah.
Could you just go back to the photo for a second?
Sure thing, yeah.
That's what they just
Yep.
I wrote CY minus cos, it still works.
Yeah, did it go in the opposite direction though?
It's going anti-clockwise.
Yeah, if you draw your unit circle, you'll see why it goes anti-clockwise. Now, what you're doing if you're going minus minus is the same as going plus. And what that means is you flip the y, you know, so you're saying that the y goes up instead of down. Yeah, did you want to
Why is it made of circles? Take another line.
Yeah, it's made out of circles because I call it ellipse, and this is what draws a circle. Alright, so that's why it's made out of circles. Does that make sense? Okay, so this method here, ellipse, will draw a circle.
Yeah.
And this x and y square is going to draw the circle, and then 10, 10 means the width and the height. So we calculate the values for x and y, and we draw an ellipse at that point. So that's why it's made out of circles.
Oh.
Yeah, if I wanted it to be made out of lines, I would type line. But then I do have a little problem with line, in that a line needs 4 parameters. So I need the previous value for line and the next value for line. So I would need probably 2 extra variables. Does anybody else want to ask me any questions before we I'll get you guys to try something for yourselves? Yeah.
I know you said yes to it, but I can't remember.
Go for it, Jack.
It was the background. Because you're not calling background, that's why it's printing so many.
Yeah, cool. Great question, right? Let's try, something interesting. You guys have figured this out yourselves already. If you go BACKGROUND 0, and then I zoom out like this, click the stop button, run it again, and then it just looks like the circle is moving in a circle. Why is this? Because I'm wiping the screen each frame and redrawing the circle at a new position. Alright, so that's why the circle is appearing to move around the outside. How do I make it go slower? Yeah, if I change this number to be a small number, so if I basically make that a 10th, it's going to move way smaller. Alright, James Bond style, huh? And if I want to make the ellipse bigger, then I change these two numbers here. Let me make it 50 and 50. So now I get kind of slightly bigger ellipse, a big white circle that's moving around the outside of the screen. Okay, it's time for you guys to write a program. Okay, I'll put this code up, and here's what I want you to think about, right? What I want you to do is modify this program in 2 very important ways. Number one thing I need you to do is use a variable. In fact, I should write these up, okay? So you don't forget, and there's no confusion about what you've got to do. The radius of that ellipse is currently hard-coded. That ellipse is drawn 10 width and 10 height. Okay, number one thing I need you to do is use a variable. How are we doing for time? It's nearly time for a short break. Let me write these notes up, then we'll take a short break, and then we'll come back and you can crack on with this problem. Use a variable to control the size of the ellipse, okay? Okay, use a variable to control the size of the ellipse, and do something with that variable. Like increment it each frame, or decrement it, so that the circle grows and it gets smaller as it's going around, okay? Number one thing, or it should grow or get smaller. It'll grow if you add something to the radius, obviously it'll get smaller if you subtract. Try subtracting it and see what happens when you specify it. Eventually it'll get to 0, and then what happens, it becomes a minus radius. See what happens. This is for the ellipse, okay? Next thing I want you to try is setting radius, the radius value that we're using. Set it to be a small number initially. And then try changing it each frame.
Yes.
So I want you to change that value, that value for radius that we're currently using. Try changing it each frame, see what happens. Increase it, what'll happen? What shape will you get if you increase it? Spiral? You get a spiral. You get a spiral. I like to say spiral with a strong Dublin accent. There used to be a guy There used to be a guy on Big Brother once, and he was called Spudon. Do you remember Spudon? He was a DJ. What's that? Spudon, the DJ. Yeah. I used to think he was cool. So now whenever I say spiral, I always like to say spiral. Okay? So, we're going to change that value each frame. The next thing I want you to try is try some random colors, okay? Does everybody know how to make random colors? Okay, so we know we've got stroke, fill and background to change different aspects of it, right? They all take 3 numbers, the RGB values. So what you do is, for either of the RGB values, you instead of using a number like 200 or 300, put in random, R-A-N-D-O-M 0,255. So this is another one of those methods similar to sine and cosine, but what that will always do is return you a random number between 0 and 255. So you get random colors. And that's what I want you guys to do, and see if you can change it to draw beautiful colourful spirals of various forms. If you want to be really cool, try also changing the values for Cx and Cy and see what effect that has. Alright, this is a matter of experimenting with these variables and just playing with the variables to see what happens until you get an effect that you like. And when you get an effect that you like, upload it to the Slack so I can see what shapes you're drawing, okay? And then let's take like 10 minutes of a break and come back in 10 minutes and we'll crack on with this. And by the way, this is only the beginning of the beautiful things you can draw using sine and cosine. There's a world of colour and beautiful geometric patterns. Yeah. But we only have half an hour left, so let's just do the spiral and see how we take it from there. Alrighty, so I guess most of you figured this out already. First thing I might want to do is change that to be a smaller number. So my circle now moves a little bit quicker. Next thing I probably want to do is instead of going background 0 each frame, I'm going to comment that out. So what that will mean is every time it goes to redraw the screen, it will have the old circles still there, and it won't draw the screen, won't refresh the screen every time around. Alright, so last thing I want to do is I want to probably set the radius value. Instead of setting it to be 200, I'm going to start at some small number. I mean, I can set it even to be 1. Doesn't matter, we'll just draw like a whole lot of circles into one place. And then down here what I want to do is increase that value for radius. So you can do something like radius plus equals to 1, which means add 1 to the radius every time you draw one. And then you get this spiral shape hopefully. So you can see that it's adding 1 to that radius value every frame around. So therefore when it's going to calculate those x and y values, it's calculating them with a different value for radius. Another thing I thought is kind of fun to try is, second thing is taking this value for 50 and 50. Let's change this to be something different. Okay, so let me make another variable here, and I'm going to call this small radius. And let me set small radius equals to the value of 50. You'll like this, okay? So small radius is, in fact, let's make it 25. Okay? So if I want to use this down here in an ellipse, that small radius should be probably why small radius multiplied by 2? Can anyone tell me? Why do I multiply it by 2?
Because it's radius.
Why don't I just use small radius here?
Because it always looks for the width, not the...
Because this is the width of the ellipse, not the radius of the ellipse. The width is the diameter. So you take the radius and multiply it by 2. And then you can do interesting things, you know, so I can also modify the values, you know, what's happening to small radius. An interesting thing to try with small radius is to subtract something from it. So you go minus equals to 1. So each frame around what it does is subtract something. Yeah?
What was the original value for small radius?
I gave it a value of 25, which is, you know, a diameter or a width of 50. And now if you do this, click on the play button, what happens is it starts with 50 and then it gets bigger. So maybe I want to start it a little bit bigger than 50. Small radius, if I set that to be 50, then I get quite big circles. They get really small and then eventually you get a negative radius, like that. So it's just another kind of a shape, right? This becomes kind of okay, just doing these spirals in this way. Okay, but then there's something else kind of cool you can do. which is interesting. And hopefully you'll learn some kind of important lesson when I explain to you what's going to happen here. Okay, let's jump back to our circle. Sorry, does everybody understand what I've done there? All I've done is this value for radius, I started at some number and then I increase it, and that's what causes the spiral effect. By the way, spirals are really important. You know, if you do a Google search for spirals in nature, it's really well worth doing this. Spirals are everywhere. Spirals are fundamental to how the entire universe works, if you want to think about it, right? Look for this. Spirals in nature. We can get on the internet here and look at images here and suddenly discover there are spirals everywhere. The world is made up of spirals. And if you start looking for these, you find them all over the place, right? Everything from the arrangement of the leaves on plants right the way up to the entire universe itself. And in this class we have discovered something, you know, very fundamental about how the universe works, haven't we? Can programmers do this? Yeah, we can. We can make models of how the whole universe works. That's what games are. You know, they're little models of tiny universes with their own sets of rules and everything. And we can make things based on the real world, because now we know how spirals work.
In my school,
What's that?
in my school there was a poster that had the Fibonacci sequence.
Ah, Fibonacci
And it was,
sequence.
so it was like this, and it had like the numbers representing like how. I didn't understand it, but for some reason the Fibonacci sequence really grasped.
Yeah, we'll make the Fibonacci sequence, and we'll make a spiral based on the Fibonacci sequence. Fibonacci sequence. Have you heard of the Fibonacci sequence? So, where have you heard of it from?
Da Vinci Code.
The Da Vinci Code. So, the Da Vinci Code. But interestingly, the Fibonacci sequence was discovered by a mathematician, but the Fibonacci sequence is another natural sequence of numbers. If you ever feel bored on a summer's day and you're wandering around France, in Paris, and you happen to see some tournesol, some sunflowers, I encourage you to go and take all the seeds off the top of the sunflower and count them. It's always a Fibonacci sequence number. Amazing, isn't it? So, what I wanted to show you, this last thing I wanted to show you today, if I could get something maybe to clear the board a little bit. I'm going to turn this thing off for a second. Plug that out, maybe it'll go away. Can I just borrow a page off somebody just to give the board a bit of a wipe? Oh, even better. Thank you. Awesome. Everybody look up at this, right? So this is something kind of amazing, right? So pay attention here. This is well worth your attention. I promise you this is going to be good. So, looking at